Hello and welcome to week 3 of the physical science class. Um, this week on the assignment we are dealing with Newton's laws, as we also been discussing in the class. So quickly, I want to run through this assignment. It seems to be a pretty simple and straightforward assignment, but I want to run through it based on some of the challenges I've seen my students have in the past. Like I said initially, download the assignment on the web page, which you can see on the page here, Lab 10. And when you read through this, then we can we can read through and see the simple steps you have to do to uh, do the experiment. The experiment you only have to do here is to compare both two objects to see if they are dropping at the same time. And when you get into the main sheet proper, please take note of this equation here, these two equations, because that will be referenced in your answer sheet. Of course, when you go down to the questions, you can see them referring to, here it says referring to the above equation. So this is the equation being referred to. So quickly, let me open the answer sheet, the lab worksheet where you're supposed to be doing your assignment. Here, please pay attention to the first part of the questions that tells that, based on the instructions to try to compare two objects being dropped at the same time, you have to come back here to answer these questions. So did the objects fall at the same rate? You have to provide your answer, yes or no. What if the objects are different sizes? Does that make a difference? You have to say yes or no and explain. So please make sure you answer this part of the question, because that also has is on credit. Quickly on the first question here, that says the acceleration due to gravity calculated this way works well for objects near the Earth's surface. How would you have to change the above equation, which is this equation right here, or this one? It's just being written in different formats. But how would you change this equation to reflect a change if you increase the height of the object by 100 meters above the ground? Going back to the equation, in this equation you see the explanation of what these different parameters mean. M, E, Earth's mass, F is force, G is acceleration due to gravity. You can cancel out all this and then we'll come out, and here you are told the distance of the object above the ground is R. Please pay attention to that. That is what the distance above the ground of the object. So the question is asking you, if you increase this distance by 100 meters above the ground, what will happen to the equation? How will the equation change? So in this question, I don't expect to see any sentences, any explanations. Just write down the equation. And the example I have given here is pretty straightforward. What I've put here is that if I say, instead of saying 200 or 100,000 meters, I said I increase the distance of the object above the ground by 200, what will happen to this equation? The equation will be tweaked to make sure that I add this 200 meters to R, but something also has to be done to make this equation correct to R. So as you're instructed here, read your textbook and focus on chapter 3 on Newton's law of gravitation, and then that will give you a better understanding of what you need to write down here as a final equation. Remember, only the equation receives credit. No other credit will be awarded for any sentence or explanation. I just want to see the equation. For question number 2 and 3, it's also pretty straightforward. Here you are being told to consult the textbook and pay attention to mass, gravity, acceleration, and how they interrelate. So the question here is saying, how does air resistance alter the way we perceive falling objects? Air resistance can do this because that's what it might seem when objects are falling because of air resistance. It might seem there's something going on, but if you read your book very well, you will know that acceleration due to gravity is constant. 9.8 meters per second squared is constant anywhere in the world. So read the book and you should be able to answer these questions simply. Finally, on the third question, is the force acting on a massive object larger than that acting on a less massive object? And how can you verify this without taking measurements? And I've written down here for you Newton's second law. Newton's second law simply states that force is equal to mass times acceleration. So if my acceleration is 2 meters per second squared, for example, I'm just giving this an example, and I change this mass to 10 grams, the question is, what would the force be? Will it be smaller or larger compared to if I have the mass as 2 grams? So this can simply give you an idea of how to address this question, and you have to correctly explain it in a correct sentence, and with verification let me know how this is possible without taking measurements. This is all you have for this week. Should be pretty straightforward and simple, but if you still have questions after reviewing this video, please send me an email, and as much as you can, send the email before the due dates because of the late penalty in submitting your assignment. If you have any questions, let me know, and I wish you a lovely weekend. Thank you for listening. Bye bye.